Hello everyone. Today we are going to start a new series that is, in this series, we are going to discuss how big tech giants solve their problems or using advanced algorithm and how they optimize their architectures or their applications. First we will talk about Twitter's 1 second search solution. So earlier, what happened was to refresh a tweet, to display a tweet on your timeline, Twitter required 15 seconds to display a tweet on your timeline. So this was a huge delay. So Twitter have to solve this delay problem. For that, that's the real problem. That is, what if you have to wait for 15 seconds for your tweet to appear? So 15 seconds is a huge time. It does not feel like real time. For a social media application, it should feel like a fun. It should feel like a real time. So that's what Twitter have to handle. And Twitter handle it in a really good way, really advanced way. We will discuss all that in this video. So firstly, we will discuss about Twitter's old system, and then we will discuss about Twitter's new way, how they handled all that things. So here we have to firstly keep in mind that the real problem here was searching in Twitter, that the problem was the searching was not really optimized. They have to really optimize their searching algorithms. Okay, so in older way, what they have used for their tweets to appear, they have used unrolled linked list. So what is an unrolled linked list? Unrolled linked list is a normal linked list, but in a node, in normal linked list, we store one element in each node and then we store the pointer to the next node. Okay. So in unrolled linked list, we store multiple elements in a node and then we store pointer to the next node, and then next node we also store multiple elements. And the second thing Twitter did in their older architecture was they used to do batched inserts. Insert means they used to insert a chunk of data in one way, in one go. Okay, they used to insert chunk of data in one go. Then they used to insert a batch in again one go. So in this way, Twitter used to insert their tweets. Okay, that is optimized as well, because instead of inserting multiple tweets at a single time, they used to store that tweets in a queue, and then they used to insert all that in a batch. Okay, so that's the older way. That's how Twitter used to work earlier. And that's what causing the real problem. The searching was really slow because of it, because Twitter have to, in linked list, what was the real problem? In linked list, the searching is a real problem. Inserting and deleting really take us a little time, but searching is the real problem in linked list. And second thing was batched inserts. Batched inserts also causing a time delay. So they have to handle these both things so that their delay, that is their latency, should decrease. So how they handled that, we will discuss. Why older system was slow? That we discussed earlier, batching. We talked about batching. Why batching? We have discussed what is batching and how batching works, and we will discuss that is prepend only. What is prepend only? Prepend only means a new tweets the new tweets will appear at the head of the linked list, in a start of the linked list. That's prepend only. And the second point was locking issues. So for the worker threads, the workers used to lock the system, lock the resources. Worker used to lock the resources to perform their operations, and other workers have to wait to the worker to perform its operation, and then they will get the resources. So this locking was causing a real problem, and the main problem was locking. The main problem was locking, and the maximum time delay was caused due to locking. The second problem was prepend only. The prepend only means you are inserting tweets at the head. So it also causing some time to insert that tweet at the head. So here also time is increasing. So Twitter have to handle all these problems. So they came with a really brilliant solution, a skip list. So in after it, we will discuss what is a skip list as well. The solution was two-part design, a new scheme to find tweet faster. So they have to find tweets faster as well, and they have to find a way to insert them instantly. So they have to do all these both of the things. So we will see how did both of these things really brilliant way. So here they use descending document IDs. So descending document IDs are, for example, I'm having two friends. I post a tweet, then my friend two post a tweet, then my friend three post a tweet. So I get a document ID 101. My second friend get document ID 102. My third friend get document ID 103. So 103 will stay at the first, at the head of the linked list. Uh, Here we are not using linked list. Here we are using lists. So the my second friend will my third friend will stay at the first position, and then second, and then third. So in a decreasing way, their tweets will get stored. So in this way, we will get fresh tweets instantly. So they solve the problem of searching here, finding the tweets faster, right? And the second thing, they have to find a way. Again, they have to increase their latency. So they use skip list. Skip list. Now, what is a skip list? I have took a really brilliant example for a skip list. I have to zoom it. So, for example, this is tweet. This one is a tweet. This two is a tweet. For example, this three is a tweet. So, they have to first for a linked list. In case of linked list, we have to go to one, then we have to go to two, then we have to go to three. Then likewise, we have to traverse it. In skip list we have the special way, we have the express lane. Instead of traversing the complete list, we go to level 2, then we take an express lane. Just like a highway, in a highway we take an express lane and then we go really fast. Just like that, here we will go to 1, and then we will go to 3, and then we will reach 5. In this way we decrease the latency in Twitter. So just like it explained here, the old system was slow, single lane road, just like a lane road. Whole traffic, if the whole traffic was on a single lane road, it will get jammed. So they have to create an express lane as well. So to find the tweet, you have to pass every single item in front of it. So this is a slow road, that is a single road. Then we have created express lane. This is the whole abstraction of linked list. In abstracted way, I'm explaining all this in abstracted way. So we took an express lane to search tweet faster. It is a upper level, and nothing. It's not like that we can create only one express lane. You can create level 3 as well. If you want to create, you can create level 3, and then you can have your elements at the level 3, and then you can search them again instantly. So that's your point, how you want to handle skip list, but it was a really brilliant solution. Then you take express lane, and then again, if you add multiple levels, then it will be a super express lane. That's the real beauty. And that's the real thing is concurrent skip list. Concurrent skip list means worker node. We solved here the problem of locking. So in case of locking, workers have to wait for each other, because one worker will lock the resources and then others have to wait for it. In concurrent skip list, multiple skip list can work concurrently. They don't have to wait for each other to perform their operations. So in this way, we solved the whole problem of insertion and searching. We use document IDs for searching. We use skip list for faster insertions, and it supports big of log n insertions in a sorted list without locking. Without locking, that's the real point. Allowing for concurrent updates. It supported concurrency, right? So what was the real-time payoff? This See this graph. The it says that skip list. It says that the skip list solution provided the latency of 1 second, while the original, the older system was having the latency of 15 seconds. So that's the big difference, right? tweets are now available for searching within 1 second of creation. If you post a tweet, it will appear in your followers timeline within 1 second. It will not require time greater than that. So that's the beauty. Descending document ID. So what we used here, descending document ID ensures newest tweets are found first. It ensures that the tweets that anyone that upload will go automatically at the first position, at the start position. That is descending document IDs. They arranged IDs. That is, every tweet has its own ID. So they arranged all the IDs in descending order, right? And then in second point, concurrent skip list. So concurrent skip list allows instant insertions without locking. Without locking is the real point, because mostly delay was occurring due to locking. That's I discussed with you earlier as well. The delay was occurring because of the locking. So what this makes possible? Truly real-time search. The application was really slow, and now it feels really fast. It feels like it is a real-time social media application. Okay. Instant visibility for new content, supports for latency sensitive features, and fourth point is live profile feeds with little overhead. Little overhead, because Twitter have little overhead, right? Okay, so what's the next 15-second problem? So I added this slide because if you are working in an organization that you also suffer from something problem like that, there you have to decrease some latency. So the videos like this will help you to understand how people handle such problems in past, and how you have to handle them in future, because you have to learn from your past. If you're not learning from your past, you will not succeed. So you have to see what people have done in the past and how you can improve all that thing in the future. That's what engineers do. So that's all from my end. That's all I have tried from my best. This is how Twitter did their work brilliantly. I've liked this solution, so I thought I should share with you. So thank you for watching the video. Don't forget to subscribe.